Welcome back to the channel. If you made it to episode 4, you officially passed the beginner stage. In episode 3, we talked about algorithms, how computers think, decide, and solve problems step by step. Today, we answer the next critical question: where does all the data actually live? Because here's the truth, most students don't realize early enough. A good algorithm with a wrong data structure is still a bad solution. By the end of this episode, you will understand what data structures really are, why examiners care so much about them, how Cambridge and IB test them differently, and the mindset that makes data structures finally make sense. This episode alone can add real marks to exams, so let's get into it. Let's start simple. A textbook definition says a data structure is a way of organizing and storing data. That's correct. But again, not so helpful. Here's a better way to think about it. Our data structure is a rule book for data. It answers questions like, where does new data go? How do I access existing data? What happens when data is removed? What order does data flow? Different rule books give different strength. Think of it like real life. A queue at a bank, a stack of plates, a list of names, a tree of folders on your computer, etc. etc. Each structure exists because it solves a specific problem efficiently. Let's walk through the non-negotiables for Cambridge and IB, or for computer science in general. First, arrays or lists. Arrays are fixed size in most syllabus contexts, indexed and fast to access. For example, scores gates 78, 85, 92, 60. What is a key strength? Fast access. What is a key weakness? Inserting or deleting is inefficient. An exam tip: Cambridge loves asking you to trace array changes step by step. Second, stacks, last in, first out. Think. Undo button, browser back history, stack of plates. How do they operate? Using push, pop, and pick. What is a key rule? You can only access the top. If you try to remove something from the middle, you are using the wrong structure. Third, queues, first in, first out. How do they think? Where are they used? Printing jobs, ticket lines, CPU task scheduling. Operations you can work with: Enqueue and Dequeue. What is a key rule? First item in is the first item out. Fourth, linked lists. Unlike arrays, data is stored contiguously. Each node points to the next. What is a key strength? Easy insertion and deletion. Biggest weakness? Slower access. Linked lists are very common with IB. If you're doing Cambridge IGCSE or A level, listen carefully. Cambridge focuses on precision. What do they expect? They expect trace tables showing index changes, pointer updates, stack and queue operations. They expect clear pseudocode using push, pop, enqueue, dequeue, and correct array indexing. They expect explanations like, this structure is suitable because. What loses marks? Mixing stack and queue logic. Forgetting boundaries like overflow or underflow. Writing programming language syntax instead of pseudocode. A golden rule to follow: if you can trace it cleanly, you understand it. IB tends to take a different angle. IB asks, why did you choose this data structure? They care about justification, trade-offs, and context. Strong IB answers include time complexity considerations, memory efficiency, real-world constraints. Here is an example justification. A queue is used because requests must be processed in the order they arrive in to ensure fairness. IB also links data structures heavily to case studies, object-oriented design, abstraction, and decomposition. IB's mindset is that structure supports purpose. Now, let's fix mistakes before they cost you marks. Mistake number 1, memorizing definitions only. Knowing what a stack is doesn't help if you can't use it. Mistake number 2, choosing structures randomly. Top students choose structures intentionally. Mistake number 3, forgetting limits. Stacks overflow, queues underflow, arrays have boundaries. What is a fix? Always ask, how is data added? How is it removed? In what order and how often? The data structure thinking mindset. This is where top students separate themselves. How do top students really think? 1, they design before coding. What structure fits this problem based? 2, they match structure to behavior. Undo means stack, scheduling means queue, first lookup means array or hashing. 3, they visualize operations. They see the data moving. 4, they test edge cases early. Empty structure, full structure, one element. They test all these edge cases as soon as possible. Data structures stop being scary when you stop memorizing and start matching purpose to structure. Every major system uses data structures. Social media feeds us queues and priority queues. File systems use trees, undo features use stacks, databases use indexed arrays on trees. Your phone is basically a data structure machine. Understanding this is understanding how software works. If data structures feel confusing right now, that's very normal. They are abstract, they are invisible, you can't see them working. But once they click, something powerful happens. Algorithms become easier, code becomes cleaner, exams feel predictable. You do not become good at data structures by memorizing. You become good by using them repeatedly, slowly, and intentionally. 15 minutes a day, draw them, trace them, explain them out aloud. That's how mastery is built. That's episode 4 done. In the next episode, we are stepping into something students fear even more: recursion versus iteration, and why one is not harder, it's just misunderstood. If this episode helped, like the video, subscribe for episode 5. Comment which data structures confuses you most. Until next time, structure your thinking and the code will flow.